Okay, last screencast. I'm going to derive the moment generating function of the binomial distribution. What shall I do it? We are defining the moment generating function as a function of t, which is the expectation of e to the tx, which equals, well, it's not really the integral in this case. It's not the integral, it's a summation. There is a general theory for this, but yeah. And no, start again. It's the sum over r equals 0 to n of the probability of having r successors times e to the t r. So I'll just write that out. Oh dear, I'll just write that out again. So it's this. It's the sum of n choose r, p to the r, 1 minus p, n minus r, e to the t r. Okay, that's the sum over r. Yeah, now I'm just going to rewrite that a little bit. That's the sum n choose r, p to the r, 1 minus p to the minus r, 1 minus p to the n, e to the tr. I've not done any magic here. All I've done is decompose. I'll do it in a different colour. I've decomposed that term there and split it into a minus r because of that, and an n, which is there. Should have done it the other way around. And now this is the sum over. Oh, I better change back to black. This is the sum from r equals 0 to n. So then I make the observation that this term here has got no r in it, so I can just bring it out. So it's 1 minus p to the power n, sigma over r, n choose r. Now this is clever. P over 1 minus p to the power r, e to the t to the power r. All I've done is rewrite that like that, and this minus 1 here, this minus r means it's on the bottom. So it's 1 minus p to the n, sigma over r, n choose r, p e to the t over 1 minus p all to the power r. Which ain't as bad as it looks. I'm just going to remind you of something. I'm just going to say a plus b to the power n equals, no I'm not, 1 plus x to the power n equals, well, it's 1 plus nx plus n minus 1x squared over 2, binomial theorem, n minus 1 n minus 2x cubed over 3 factorial, and so on, equals 1 plus nx plus n choose 2 x squared plus n choose 3x cubed plus and so on up to x to the n, because after that you've got n minus n and it's 0, equals sigma 1 plus, no it isn't, it's equal to 1, no it isn't, it's equal to sigma of n choose r x to the r, and the whole thing was, remember, equal to 1 plus x to the power n. Right, I can use that because look, we've got the same form, but instead of writing x there, look, instead of that x there, I've got this p e to the t over 1 minus p. So I can write this whole thing here. Look, we've gone through a bit of a diversion. Just pinch that down a bit. I'll start here. We've got 1 minus p to the power n times 1 plus p e to the t over 1 minus p to the power n. That's looking better, isn't it? That's looking quite nice. So it's something to the power n, isn't it? And we just multiply throughout. So it's 1 minus p plus, and then that 1 minus p on the top cancels that 1 minus p on the bottom. P e to the t all to the power n. Done. Done. We've seen that before. Look, that is here. If I go back, oh, I don't quite know what that is. Oh dear, I don't know what that is at all. I think it's here. Is that where we came from? No. Poisson? Oh god, I don't know. Oh, there it is. Right, so that just matches this thing here. If I click on Wikipedia again, we go up to, and we see the binomial distribution has got this value here. So now we've got that, and that's how to prove it. Okay, I'm going to stop there. I've had enough.